Today in lecture, a little bit later, we're actually going to watch some videos. That should be exciting as well. We're going to mix things up today. We're also going to have what is called live coding. So that's basically where I'm a coding DJ and I will take requests. But I'm going to try to live code and talk about what I'm coding to illustrate and review some of the concepts that we've already seen this week. And so I'll type slowly, I'll talk us through it, and then you guys can ask, well, what if you do this, what if you do this, or I'll ask myself that. And then you can kind of see how someone who knows to code also makes mistakes, doesn't know everything, and how I kind of think about problems. So you'll get to see some of that. We'll see whether this is something that we do in future lectures, either the video or the coding DJ stuff. It's kind of an experiment, whether it's exciting or not. So it's not necessarily just if you hate it today, we can not do it again. I know it's early. How did you guys like the speakers that came? I had to be out of town. Yeah? Yeah, they said a lot of good things about you guys and the TAs as well. So thanks for coming early. And next week we have Andrew Prescott Miller, who's an engineer at Snapchat, and he did his undergrad at UCLA. So he's going to talk to us about his work. Hi, Nayeli. Oh, no problem. Yeah. By the way, you guys, whenever you get here, feel free to just come inside and get yourself set up. So, welcome. And so he's going to come, and then a physicist who works here at Caltech called Sean Carroll is going to come. He's also written a lot of books about physics for people who aren't physicists to read. So he's written From Eternity to Here and several other books. He's a consultant on physics shows in Hollywood. And so if you have any questions about black holes or kind of really fun physics concepts, he's very good at explaining everything. And normally his speeches have like 500 people in them, and he's going to come talk to us. So that's really nice of him. So we are going to have a little bit of videos, a little bit of live coding today. But first we have a couple concepts that I'm going to review, so it's kind of more traditional slides. And the last logistics thing is kind of the day after the lectures. They're all automatically recorded with the slides and my voice, and I'm now pasting them into the textbook itself. So the lectures are there. And that just means that if there's a concept that you remember was well explained or differently explained in lecture, you don't have to watch the whole lecture video, but you can kind of push play and then scroll through until you see the slide, and then kind of listen to that explanation again. Let's see, what else? Today as well, in the lab sessions, we're going to offer two, one in the morning and one in the afternoon, one-on-one tutoring sessions. And we might continue to do that as well. And if you're interested in one-on-one tutoring, send me a direct message on not on Snapchat, on Slack. On Slack, just with like a couple words about why you want the tutoring session, because if there's more people than we have space for, we'll just pick the people who need it a little bit more urgently for material this week. Some people might say, you know, I'm 5 weeks ahead and I need help with reinstalling my operating system or something like that. We're just going to keep it to material kind of this week to make sure that everyone has a chance to ask questions. That also means if you give the subject of the tutorial that you want, say, oh, I really didn't get while loops, because we have a one-on-one with while loops. If there's 2 students who want while loops, then we might take 2 students instead of a one-on-one and have a breakout session on that. So that's why we ask that if you want the one-on-one tutoring, just send me a message. And it doesn't mean that you're necessarily behind. You might even be ahead and be curious about stuff. Some of the people with the one-on-one might actually just want more in-depth than I'm able to go into in lecture. Okay, so let's get started this morning. Back to control flow. So we saw this a little bit in the last lecture. Control flow is the order in which computer code is executed. Sometimes Python is executed one line after the other. But sometimes there are a variety of mechanisms that allow you to skip over code or to only execute certain code if conditions are met. So if the weather's nice, go outside, else stay inside. Or to execute the same piece of code over and over again until some condition is fulfilled. I think in lecture last time I gave the example of me walking, putting one foot in front of the other until I reach the wall. And when I reach the wall, I should stop putting one foot in front of the other. Some of you who had the breakout session with Ipython saw that many of you did an exercise where you had to describe to her the exact steps how to draw a square, how to draw something. And you saw that if someone is just following your instructions, if they're not using their human intelligence, you have to be very precise when you describe how to do that. And it's the same with anything in computer code. You can't assume the computer is just going to logically know to do the right thing, like a human, like a brother or sister, like a parent, like a friend. It's very literal-minded. So part of learning to computer program is to learn to think in a way where the thing that you're speaking with your computer code is extremely literal-minded. It's not going to add any interpretation. So you have to think of every edge case, every what if, and make sure that while you're coding, that you've provided for that as you code. So this form of if the weather's outside, then is nice, then I'll do this. If the weather outside is bad, then I'll stay inside and code. It's called a conditional in Python. And Python allows us to capture this with if statements, and each if statement is followed by a block of code, where a block of code is one or more lines of Python code to execute that's indented to indicate that the lines belong together. And again, this is a little bit of a review from lecture last time, and you might have already seen some of this in the lab. So just like the bullet points here, we can see that the bullet points belong together because of the indentation. And indentation is important in Python. So in general, the general format of an if statement is if some expression that will return a Boolean, then the colon, then a block of code. Then these elifs mean else if, and those are optional. You don't necessarily need them, but you can have as many as you want. Yes, Nico?
And those ones only run if the first if returns false. So
that's correct. Yeah. So we're only going to take questions today, not explanations, just because we want to keep on track with the lecture. But that's a very good point. That only if the first expression is false do you ever get to any of the following code. Only if the next expression is false do you get to any of the following code. So of this entire section, just one of those code blocks will be executed. So if there was another if, it would not belong to this if. So each if statement kind of begins a new string of, you can add elifs or elses, and those all belong to the same if statement. If I were to add, and we'll do some of this in the live coding, if I were to add a new if statement, then that starts a new chain of logic that doesn't belong to the chain above. Within every if statement, only one of those code blocks is going to be executed. So if you start a new if statement, then, again, one of those code blocks may be executed. So if I remove the else, it could be that all of the Boolean expressions are false. And that would mean no code was executed. Else is what happens when everything above it is false. And that's also optional. The only thing that is required of an if statement is an if and some code. Everything else you can chain together and it's optional. And it really depends on the logic of your situation. Sometimes you're going to have a bit of code that you always want to run. No matter what, whether it's sunny outside or cloudy outside, you want to get dressed. What you wear is going to be different, but you're always going to want to get dressed. So that's the things that you're always going to want to do independent of the logic above. That goes in the else. And we'll do more of this in the live coding. So just to elaborate, an if statement always begins with an if. If Boolean expression, don't forget to add the colon. The code block can be as many lines as you like. They're all indented at the same level. Don't forget to indent. Elif statements are optional. You can add as many optional elif statements as you want. In this example, there are 2. You could have 0. You could have 5. Whatever you choose. Else statements are also optional, but there's only one. The code following the else statement is executed only if no other Boolean expression evaluated to true. Here's an example with code. So we have a latitude, we have a date. We're checking, here's a Boolean expression. If the latitude is equal to minus 5.126424, and the date is equal to February 1st, 2017, then this is grading you. It says you're correct. If the latitude is positive 5.125424, well, yeah, I have a typo above. I probably should be 5.125424. Then your latitude is positive instead of negative, and keep trying. So it gives you a hint on what might be wrong. So else, it prints you're way off. Keep trying. So in this case, we have a positive 5.125424. So it gets to the first section, and this isn't true. That Boolean expression is not true, so it skips that line of code. Then it checks if the latitude is equal to that number, which it is above. So it prints your latitude is positive instead of negative. Then on a new line, keep trying. And it never gets to this block of code, and it never gets to the first print line in this example. So this would be perfectly valid if we removed this way off, keep trying. It also would be perfectly valid code if we removed this elif statement. The code would still run. It wouldn't print anything. So you can see here that there's a lot more, many more hints that you could give if someone's off in their date. Imagine here we can see that someone has typed 2016, but the date should be 2017 if you're correct. So we could have more elif statements checking for hints on that and say, oh, if you have a 2016 in your date, then you might try putting a 2017 in your date. And just a hint on this, if you get yourself, if you're totally lost in a problem, you have no idea what you need to do in terms of how to code it, if you know it needs a while loop, or if you know it needs an if statement, if you know it needs a for loop, if you have some idea of what it might need, what you can do is go to the textbook and copy and paste one of these very general without the code. It's just kind of sketching the code almost. And we know we have, once we paste that in, we can say, okay, I know I have to reason about something, so I know I need an if statement. Let me copy and paste this in. Okay, so I know I need a few Boolean expressions. What are my Boolean expressions going to be in this case? And then think about how you would describe it to a friend. Ibuke, me, someone else in the class. If they were very literal-minded and could only listen to your instructions and not do anything else. So how would you describe to them what to do? And then kind of fill that in the code. And that will also get you unstuck and get your juices flowing and at least get a little bit of code on the page. So you can go in the textbook, find some example code, copy and paste it in, and then try to change the code to work with your situation. So indentation is important in Python, and the programmer, you guys, can choose whether to indent with a tab or with spaces, so long as you're consistent throughout your program. If I use tab one place and spaces another place, Python will say invalid syntax. I don't like that. So just pick something. We recommend that each level of indentation be 4 spaces. So if you want to indent once, it's 1, 2, 3, 4. If you want to indent twice, it's 1, 2, 3, 4, 5, 6, 7, 8. But you can also indent with a tab, 1 tab, 2 tabs, etc. Every Python programmer may, at some point, get indentation errors. It just happens. Sometimes you're copying and pasting code from elsewhere, and that code uses tabs instead of spaces. Sometimes you're typing very fast, and you don't indent correctly. You're missing 1 space or whatever. So it's something that every Python programmer sees. In many other languages, programming languages, instead of indenting, you use braces or brackets to indicate that groups of code go together in a block. Python chose not to do that because it's a little bit easier to kind of look at and see what's going on. It also means you're not having to type all these braces and brackets. But that means, as a trade-off for that easiness, that we have to sometimes deal with fixing the indentation errors. So how would I fix this code? What lines would I change if it's currently indented correctly? We have to indent a few lines. Yep. So indent that print, and then indent also that print statement. So at this point, if you're following along just from the lecture, you're ready to attempt the notebook problem R7. So in this case, we're going to use if statements to check to make sure that a variable that's been defined is in the correct range. Latitude measurements should range from -90 to 90, and longitude should range from -180 to 180. And if we're going to go ahead and use this code and send it to NASA, we want to make sure we're not sending 360 or something that's going to cause it to crash. So that's the kind of motivation behind this code, is to try to check that. And again, if you get a little stuck here, copy and paste an example of some if statements. Then just look at a piece of paper and kind of write down how you would describe how to do this to a friend, or how you would write it in mathematical language. Maybe define a variable x, and then check whether x is greater than or equal to something. Look at what operators you need. And then finally try to fill out your code. Even if your code is wrong at that stage, it doesn't work, it doesn't compile, at least you have a start. And then Python might give you an error. You might test it for a few different values and see whether it actually works. But it'll get you started with that. So we already talked a little bit about while loops. So oftentimes in programming and in life, you'll want to do something more than once. With a computer program, the great thing is that you don't have to type it more than once. And this is something that we'll use often in scientific data analysis, astronomy, biology, etc. If we could just do the data analysis with our hands, with pencil and paper, we would, because that would, maybe be straightforward. It's easy to see what's going on. But the beauty with a computer is that you can do it over billions of DNA pairs, over billions of data points. So a loop is a piece of code that Python can potentially come back to and go over again and again without you having to type it again and again. One way to have Python execute the same code multiple times is to use a while loop. While Boolean expression, block of code. If the Boolean expression is true, then Python executes that block of code. Then it goes back to the while loop and tests it again. Only when that expression ends up being false does it stop. And then the program moves on to whatever's after the while loop. And we can tell whatever belongs to the while loop because of that indentation of the code block. You might notice that a while loop has the potential to run forever if it runs once at all. So if you ran the following, actually Python anywhere will basically give up because we have while true, which is always true, print still running. So this loop will print still running, then check if true is true. It's always true. Print still running, check if true is true, and keep doing this. So you could print something for as long as your computer stays on, just printing. Still running, still running, still running. So that's useful if you want to, I don't know, spam your friends with messages all the time or whatever. Do something that's over and over and over again forever. But most of the time, as a programmer, you don't want the while loop to run forever. You want it to stop at some point. How do we do that? In that case, we make sure that within the code block, we're changing something that has to do with the Boolean expression. So that eventually what we're changing changes the value of the Boolean expression from true to false. And at that point, it stops the while loop, and we can move on with our life. So in this case, we're going to count from 1 to 9. So while count is less than 10, we're going to print count is whatever it is, and then we're going to add 1 to count. So count starts out at 1. Then we're going to print count as 1. Then we're going to change count to 2. Go up. Check if 2 is less than 10. It is. Print count as 2. Add 1 to count. Now it's 3. Check if 3 is less than 10. Print count as 3. Add 1 to 3. We have 4 now. Check if 4 is less than 10. Dot, 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 dot. Eventually, we reach 9. It's going to say count is 9. It's going to add 1 to 9. We have 10. Then it's going to check if 10 is less than 10. 10 is not less than 10. So it's going to say, hey, I'm done with my while loop. We can move on to whatever code's next. So what would happen if I changed count instead of starting out at 1, if I started count out at 10 at the very top? Nico? It wouldn't run out. That's correct. Here we see a couple features. We have a Boolean expression that involves some sort of quantity that was initialized or set to some initial value that changes, that the code block changes throughout. So we kind of have 3 pieces to our while loop. The initial value of something, the Boolean expression that tests what that something is compared to something else, and then changing that something so that eventually it's modified and the while loop will stop. So that's one good thing if you're writing a for loop or a while loop. If it's not running, check what your initial value is and make sure that it runs at least once, and you can do that in your head. If it's running forever, how you debug it is you make sure that you're always updating something that eventually will be false. So there's a couple things we're going to learn that are useful in both while loops and later for loops. And these are specific to Python, but there are other kind of ways of doing this in other languages. So one is something called continue, where you just type continue. And it allows the programmer to go to the top of a while or a for loop without executing any additional code. Continue is often used within a conditional, within an if statement, where if that's true, we know we don't want to do anything more with the rest of the code block, that iteration of the loop. So here's an example of that. Imagine if we consider 4 a bad number for whatever reason, and we don't want to print it, but we want to continue printing numbers after 4. This time I'm starting at 0. While count is less than 10, I'm going to add 1 to count, so now I have 1. Checking if count is 4. If count is 4, I'm just going to go to the top. So that means that when count is 4, we'll never reach that line. So continue just goes to the top when count is 4. So this loop will print 1, 2, 3, then 5, 6, 7, 8, 9. They'll skip 4. And so continues, a useful logical thing, you can write your code in a different way. We can move the print statement around so that you didn't need continue, but continue basically means, okay, we're going to go to the next, we're going to go back to the while and ignore everything below that. Break is also a very useful thing, but rather than going to the top and just going to the next stage, break jumps out of the loop entirely. It says we're done. So as soon as you get to a break, it doesn't print anything else. You go to the next line of code after the while loop. You're just completely done with the while loop. So in this case, this will print 1, 2, 3. You reach 4 and break. Then the whole thing's done. And it doesn't print 5, 6, 7, 8, 9. So this is also very useful if, say, you're trying to get to something. Say you're saving up money, and you're like, well, my money in my bank account is less than the price of a car, less than the price of a college course, less than a price of food, whatever it is that you're saving up for. Keep working, keep working, keep working. But then as soon as you get that much money, stop working. Retire. Buy that thing, and then you're done. Life doesn't work quite like that, but code can. So you can say when you reach a certain situation, I'm done. We're done with this. We're going to move on in our code. Note that we can have nested loops or a while loop within a while loop. Using continue or break within more than one loop will apply to the loop that's just above it. So if I break out of a loop in a loop, it'll just break out of the inner loop, and the outer loop will still keep going. So I'll give you an example here. So this is a continue and break example. So this also shows us that we can have if statements within code itself. So here we have different levels of indentation. One level, and we have the if statements, and then we have another level. So in this loop, we're going to skip 4 because there's a continue there, but we're going to go back to the top of the loop. We'll print 5, 6, 7, and then if we reach 8, then we're done with the loop. So this will print 1, 2, 3, skip 4 because of the continue, 5, 6, 7, and then done. So you can use both continues and breaks. This is something that you'll often see in other people's code. There's usually a way that you can structure your code so that you don't need continues and breaks. But it's good. Part of the skills that we're learning in this class are not only going to be to write our own code, but how to read code and see what it's doing. Because often, say you're working in whatever profession you end up doing, you may be a software engineer, maybe not. If you're working as that, you're going to, at some point, hopefully, need to use someone else's code to run it, to see what it does, maybe make small changes to make it do what you want it to do. And then you're going to need to understand how to read it. So some of these more advanced concepts are more to understand when you go through the logic, what's going to happen. So that you can be the Python interpreter and read this and say, this is what's going to happen. And then if it doesn't do what you expect, know how to change that. So this is the example problem in the notebook is the while loop problem, where we want to print out every date from February 4th, 1984 to 2017 in the format year, February 1st, just skipping the year that you were born. There's a couple hints here. And the important thing to know is because it's a while loop, somewhere in the while loop you should be incrementing a variable. That is changing something in the code block that the while Boolean expression is testing. If you aren't, then your while loop will run forever. So the next loop concept we'll learn is called a for loop. And for loops exist in a lot of programming languages. In Python, usually they're used in a way that you're working with a sequence.
You don't have to worry about the while loop. You have to keep track of the variable. You have to initialize it to something. You have to increment it. That's a lot to remember. If you forget any of those things, your code is going to be wrong. With for loops, they're kind of a shortcut because you can go for variable in sequence and code block. And before, when we were keeping track of the counts, we had to add 1 every time, add 1 every time, add 1 every time. There are shortcuts in Python that will just give me a list of numbers from 1 to 10. And I can use that shortcut, that function, and then I don't have to keep track of a count and add it, and if I forget it, something's bad. So this variable is something that you can name whatever you like, and then you can use it within the code block. During each iteration, each time we go through the variable, the variable is set to be the next item of the sequence by Python. So if my sequence was a list of numbers from 1 to 10, my variable could be x. And then the first time, x is 1. And then I can say print x. I can say print x plus 5, print whatever. I can do whatever I want with x. Then the next time, x is 2. Next time, x is 3. If my sequence is a list of names of people in the class, then I could say for name in the list of names in the class, and then the name would be Nico, the name would be Nayeli, the name would be Momo, etc. And each time you go through the sequence, that variable, which you can choose what it's called, in this case I'll choose name, is set to be the next item of the sequence, the next item of the sequence. And that's so that you can use it within the code block. Where do you get these sequences? We'll learn a lot about this next week. We're going to learn how to use lists and tuples and dictionaries in a variety of different ways. For now, we can use a Python function called range. This is kind of a shortcut to give us a sequence of numbers. So the thing with range is that it starts at 0, and then it goes up to whatever you put in the parentheses minus 1. That's just how it works. You kind of have to pick, you expect range 10 to give you 10 items. So either it's going to go from 1 to 10 or from 0 to 9. Because you need 10 items. Python picks 0 to 9. In Python, every time you start with kind of the first thing, it's actually 0. Python counts from 0. So sometimes you can tell a Python programmer, because you'll ask them to count, and they'll say 0, 1, 2, 3, 4. So Python starts counting from 0. Important to remember. So when you say range 10, it'll give you 10 things, but starting from 0. So you go from 0 to 9. You could also use the result of some other piece of code, which gives you a sequence. So the notebook problem Earth 9 uses this method. You can also create your own sequences called lists or iterators, which we'll learn about in the next chapter. So for now, we're just going to work with sequences that people hand us. We're not going to create our own sequences yet. But next week, when we learn how to do that, we'll have almost all the basic tools to do very powerful Python programs. And in week 3, we have a guest lecturer, a scientist, who works on gravitational waves. And we're actually going to be working with real scientific data and plotting various analysis and going through the same discovery that they did when they discovered gravitational waves in the data. And these same methods, how to analyze data and how to plot, those are things that scientists of any sort use every single day. Every single day. And they don't necessarily even teach you in school as you're learning to be a scientist. So already learning it now will help you, no matter what science or what kind of data that you're analyzing in the future of any sort. Do you have a question?
I just want to say something really quickly. I actually use code a lot in math class. I use it a couple times, not a lot, but I've used it a couple times to make my solving of problems a lot more efficient and to find more patterns than I did find out.
Yeah, so people find code useful for a variety of reasons. So we will have, just with the tools, I know you're getting a lot at once, so sometimes you're like, oh, this is too much. At the end of next week, we will have all the basics you need to do more advanced analysis than a lot of college freshmen and sophomores in terms of any data or project that you'd want to do. Science fair projects, help out with your math class, whatever it is that you choose to use that for. And a lot of people end up using this to do stuff like make art or make music. So people make music with, they'll have a list or an iterator of different musical notes, and then they'll do the same thing for this, and it'll make a piece of music. So there's a variety of stuff we'll be able to do with this. And if you do all the problems this week and next week, we'll have all the basic tools. So in many situations, a for loop is simpler than a while loop. These two do exactly the same thing. Print count from 0 to 9 up top in a while loop, and then print count from 0 to 9 on the bottom. So you will see many for and while loops in Python code, and which to use depends on the situation, but it also depends on you. So if you find one simpler than the other, you could always write a lot of your code starting out using one or the other. Oftentimes you can rewrite a for loop as a while loop and vice versa. It just may be a little bit more complicated one way or the other. It's important to know both, though, because we'll see both in our code. So again, we have that variable, and that's something that if you know you need to use a for or a while loop, go back to the textbook, copy and paste an example, and then change it to be something for you. In this case, count, we did for count in range 10. Count is a variable of our choice. We could call it something else. Some programmers often use variable names like x or I for loop variables. We recommend that you have a more descriptive and longer variable name to help prevent confusion or error. If you always use I, if I have a loop within a loop, then we're going to have two i's, and Python and you will get confused about which I is which. So if you use a little bit more descriptive name, then each loop will have a different purpose. It will also help you read the code, because if you have an I way down here, and it's just I, we don't know what that means. If it's called count, then we're like, okay, at least this is a count, it's probably an integer, and we can trace and search for that. At this time, you're ready to attempt notebook problem Earth 9. So in this case, the NASA API, this code that we've been working with, also gives us the option to return not just one image, which was earth.image, but many images with this assets code. So assets will give us all the images taken at that latitude and that longitude between February 1st in 2014 and June 1st in 2014. And in this case, in the code, when you have your for loop that's using the sequence assets, you just want to print each individual variable. And on the screen, it'll say assets or something like that. We're not going to do anything with the assets yet. It's not displaying the image. It's just showing you how to use the sequence that someone else defined for you, and then for variable in sequence, print variable. It's kind of the result. So your code should just add 2 lines to this. And when you run your code, it should end up, I know the answer because I searched this myself, there's 8 images between that date and that date. At this point, you're ready to attempt the capstone problem. Now, all the problems up to 9, everyone should be able to do within class. Problem 10 is a little bit more advanced, and it's kind of putting together knowledge, and it's more like the problem that you'll get in a job or in a scientific project on your own. It doesn't have as much guidance. So it may be that you get frustrated or you're not able to do all of problem 10. I encourage you guys to work together and get through it as much as you can. What we're going to do is on Monday at midnight Monday morning, basically, so you have until midnight Sunday night to finish. We're going to look at everyone's notebooks and make some comments and hints. And then you're kind of done with the notebook for week 1. We can move on. You should have everything for problem 9 done completely, and then problem 10 as much as you get to. But it's really designed to be a cool and fun problem where we're going to try to use the Landsat satellite imagery to, in a square, figure out the cloud cover and how it's changing over a period of time, and use that to make a guess as to whether there's a lot of rain there or not. And this is an example of, and we're going to, this afternoon, go more into the Landsat history. People are, with more precise functions and more precise analyses, actually doing this with this exact same data that we are. So if you did this analysis for a place that no one's ever done it before, you could be the first one to talk about the cloud cover in this portion of the world. And report that result on your course blog or in the Slack. So basically here, in part 2, so far I've been giving you a latitude and a longitude. In part 2, you're going to figure out a particular place. In California, I recommend, but I also say if you want to do it elsewhere in the world, that's fine. Then use its latitude and longitude to return some Landsat 8 images. Note that if you remove the end date from Earth assets, that'll retrieve all the images up to the present day. Then you get out some images and display them using a for loop and the display command as you previously did. So in part 1, there's an example of this, where we're using assets to get all the images between February and June in 2014, and then we're calculating the fraction of white pixels in the image, printing that, and then displaying the image. So this gives you an example where you don't have to write all this code from scratch. You can copy and paste that in part 2, and in part 2, what you're going to instead do is maybe change the dates, maybe change the latitude and the longitude, and see if you can get something that looks interesting to you. But where you explore is up to you. So let's see, how much time do we have here? Okay, we have about 20 minutes or so to do a little bit of live coding. Okay, this is fun. Let's see. Okay, so we were dealing with numerical types before using this type function. It's an int. Uh-oh. See? Live coding. So here I got an error because I put 2 parentheses. And Python is helpful when you have an error. Often the errors will have names. In this case, it's a syntax error. Syntax often means it's a problem with the way that you're typing Python, some sort of typo. And it even helpfully has this little caret right here that's pointing to the error. So if I very carefully read this, I can already see that it's like, okay, I was fine up until this parenthesis right here. That's when I screwed up. So then you can go back, and in my next line, I removed that extra parenthesis, and now it's gone. So I can also define a variable. Let's see, x. I'll do a more descriptive variable. What type? Actually, I'll just do x. We'll do x equals 5. So then I'll check if type x is an integer. I will print x plus 9, and else I will print, let's see, x. So that printed x plus 9 because x was an integer. Now if x is instead a string, and I go back using the up arrow, I can go back to my previous code. We're in the Ipython Interpreter. which is useful because it lets you try out code very quickly. If you're like, will this work or will this not? If you don't want to mess up your notebook, if you want to try out code, you can use the Ipython interpreter. The only thing is that sometimes it's a little hard to see the indentation because on your first line, you have this getting in the way. So you have to imagine this is not here, and this if is all the way over here. And then the indentation makes sense. The print is indented. This print is also indented. So that's just something that can sometimes trip you up. So now x is instead a string, so we're not going to add 9 to it, which is good. It's now Christine. So let me change this. I'm going to use the up arrow to use the same code again. And I'm going to add an elif, because I don't want to try to add something to add a string to a string unless the type is also a string. Elif type x equals string. That's a string. Then I'm going to print x plus is cool. Yeah. I am cool. Thank you. So now I'm going to set it back to an integer, and we'll execute this again using the up arrow. And it's now adding 16. And the reason why this is nice is because we can kind of work with variables like x without worrying about their type until we actually go ahead and use them. So that means you don't have to type x as an integer all the time. It's just when you go ahead and add something to it, you have to make sure that you can do that either mentally, or if you really don't know, if the code is ambiguous, you have to actually check the type here. Let's add an else to this. Else print. What am I? Okay, so now x is still, the last time we set x to anything was up there, line 10. We set x to 7. So x is still 7, and we're adding 7 to 9. Now I'm going to change x to be a none. And if I execute this code again, x isn't an int, so that code isn't executed. X isn't a string, so that code isn't executed. And since none of those if or elif statements were true, it's going to print what am I. And note that we could add more elifs in there. We can check if the type of x was none and say, I know what I am. Let me see. This will let me go up. Might have to type this again. Yeah, so I'm going to copy and paste this, this part, and just going Control-C, and I'm going to paste that in and fix the indentation. So there's also there's something that Ipython helps you out with, which there's what's called a magic function called paste. And we'll see if this works. But what that does is it takes whatever you've copied and it tries to fix your indentation for you. Because sometimes when you copy from Ipython, because it has those different lines, it gets the indentation wrong. So paste tries to automatically get the indentation right. Let's see if that works. So now at least we see that we have the indentation right here. Well, I didn't do it's not pasting right. Okay, so this is something that's sometimes hard with Ipython, is to get the indentation right if you're doing multiple lines. So I won't do that example because I don't feel like typing a lot more. But one thing that we'll learn about next week is how to put your examples in a file and then run that file. And if I put my examples in a file, which we'll learn about next week, then it's a lot easier to see the indentation because you're not having to type it in real time. And it's a lot easier to also reuse code and edit it. So just like a notebook, which you cannot save all your code, but then you have to go in there and click everywhere and say execute, execute, execute. If you put all your code in a file, then you can just say run my code, and then it'll run. So we'll learn about that. Before we go on, does anyone have any DJ requests for type? Yeah, what's up? Yeah. There's another section on for loops, but we'll do a for loop. So for count in range 10, colon, not that, typo, indentation. And what I'm going to do is two things. I'm going to print the type of count, which should be an integer. And then I'm also going to print count itself. So here, again, counting from 0 up until 10 minus 1, everything's an integer, and we have it do something over and over again. We'll do more for loops as well. Yeah. I can show you as well when we learn sequences. So for name in, let's say for instructor in Carrie, let's see, I'll call her Dr. Nugent, and then Dr. Moran, and then future Dr. Turker. Print, I'm going to use tab completion here. So instructor. I'm going to type it. Instructor. There we go. So let me just do that again so that. So we'll learn how to do stuff like this next week, how to specify your own sequence. But each time instructor is going to be the next thing in the list. So first it's set to Dr. Nugent, it prints Dr. Nugent. Then instructor is set to Dr. Moran, it prints Dr. Moran. And then it's set to be future Dr. Turker, and it prints future Dr. Turker. What's that?
Why did you use brackets instead of parentheses?
That's a great question. So next week we're going to learn the difference between, this is something called a list, and there's also something called a tuple. Both of them work. Tuples use parentheses and lists use brackets. And if you've seen Python before, you might have seen both of them, like I know that Nayeli has. A tuple is something that you can't change. Once you change it, once it's there, you can't change it. So if I make a tuple, then it's going to be that way for the rest of Python time. For a list like this, I can change it. So the reason why I used a list is later, if I have a variable set to be this list, and this is, again, material from next week, so don't worry if you don't follow. Say I will actually create a variable called all instructors, and then I'm going to remove the colon. So print all instructors. So now, it's a few years from now, and future Dr. Turker has gotten her doctorate. So I can set the second item, and Python counts from 0, so 0, 1, 2. I can set the second item to be Dr. Turker instead of future Dr. Turker. And then I can print all instructors, and now it's changed. So if I use what's called a tuple, it won't let me change it. So it's useful if you have something that shouldn't change, like, say, the list of the students in the course that shouldn't change throughout the course. If someone tries to change it in the code, it'll say, no, you can't do that. Syntax error, not allowed. So if you have something that shouldn't change, Python lets you do that. If you have something that might change, for example, whether Ipython has a doctorate or not, that might change, then we can allow people to change it in the code. So that's all material from next week, but it's a little preview to that. So let's do a little bit of live coding having to do with variables. So in our example of for instructor I'm going to use now all instructors, print instructor. Okay, so now Ibuke has her doctorate, so you can tell your committee and we're all done. So I can call that variable whatever I want. I could call it for best instructor. But I have to make sure to call it something that's used everywhere. So here, I can't call it best instructor here and call it instructor here. Python will say, I don't know what this is. What's instructor? I don't know what that is. So let's try it. Oh, this is a good one. So it doesn't say, I don't know what that is, because we've used instructor in the past. Instructor was set to be Dr. Nugent, went through the loop, Dr. Moran went through the loop, Dr. Turker went through the loop, done. Instructor's still hanging around. So because the last thing instructor was set to is Dr. Turker, we have Dr. Turker 3 times. So that's kind of a strange Python bug. It's a code bug, basically. So this could happen in your code, and you'd be like, what's going on? Why is it printing Dr. Turker 3 times? So what happened here is that we've used this variable in the past. So Python isn't complaining about it because it's set to something, but it isn't the variable we're using in the loop. So let's change that to be best instructor. So now it goes through and it's Dr. Nugent, Dr. Moran, Dr. Turker, as it should be. And then since the last thing it was set to was Dr. Turker, if we use it now, it'll be Dr. Turker. If instead we tried to do something that we've never used before, so really never defined, then we get a good error. This is a little more descriptive. If you get Dr. Turker 3 times in a row, it's kind of hard to debug. Here at least it tells you what's going on. We have an error. It's a name error. Because the variable name, really never defined, is not defined, which is not a big surprise, because I've named that variable very well. It's really never been defined. So again, that's something that you can pay attention to the errors. You can read this error out loud. It's a name error. Then read this out loud to yourself. Name, really never defined, is not defined. So then IPython even tries to help you by pointing to the line of code where that happened. And then you can kind of see, oh, the variable I was using in my for loop was best instructor, and what I'm trying to print is really never defined. What I should be printing is this variable. Okay, did you have a suggestion?
I have a question. So for the previous
Here, look. There you go.
So for the previous code, like where Dr. Turker was hanging around,
Yeah.
Is there any way to protect that?
That's right. So you could, that's a good question. Is there any way to protect that? So we have instructor hanging around, so we could set instructor to be none. And we could also set best instructor to be none. And then when we go ahead and try to do the wrong thing and print instructor, it is defined, though. So because it's set to none, it's set to something. So in terms of having it be a name error, I think how you do this is something like del. Let's try this. This is what live coding is all about, finding stuff that you might not even know. So instructor see if this works. So now, let's try this. Now it gives us name instructor is not defined. So there's a Python code word that will say, really forget about this forever. Never use it again. And then if you try to use it again, it prints the real error. So that's one way to do it. People typically, in their loops, don't do that. When you're reading Python code, you won't see del after the loop for the loop variable. But that's one of the reasons why it's extra important that you name your variables very descriptively, and that when you read your code, you read through it and check. In addition, what we're going to learn about, I think it's in week 4, is something called code testing. And these are ways where you can check whether your code's correct. So if you know mentally what you expect it to do, you can write what's called a test function, and then you can have that test function execute every time you run the program. And it will say you're coding and you made a bunch of changes, your test functions will say you broke something, and it'll tell you what you broke.